This is a topic we want to talk. I want to share with you today on today's morning. 5G industry deployment and evolution. Yesterday's morning, we introduced some communication network development, some key technologies about the radio network, about the mobile communications, right? So today we want to introduce some applications in the 5G industry, 5G industry deployment. So first, this topic we divide into four chapter. First one is 5G vision and application scenarios. Actually, on yesterday morning, we mentioned a little about the 5G vision, especially the 3G typical application scenarios. Right? Today, we will introduce more details on that. And for the protocol standard, well, yesterday we introduced the release and the organization 3GPP, right? Do you still remember the 3GPP? And the 3GPP will define the different release for different racks, right? So we will introduce the standardization and the industry progress. The chapter 3 is for the transformation and network evolution. For some different scenarios, we can choose different technologies to reach different requirements. And last is the global commercial use plan and process. Okay, now we check the first one. Okay, on this page, I have a question. The topic is a question: what is 5G? So we need to know the first concept. What is 5G? And we know 5G. The first release to define the 5G is release 15, right? Release 15 in 2015. The IDUR defined the name of 5G as IMT 2020. So after that, 3G was referred to as IMT 2000 and 4G as IMT 2010. So we need to discuss a question: can 5G be understood as 4G plus 1G? The real word. Can 5G be translated to 4G plus 1G? We see that 5G cannot simply be understood. The conclusion is cannot be simply be understood as 4G plus 1G. Because we see 5G is not only an improvement over 4G, such as faster speeds. Instead, 5G introduced a completely new improvement over the new technical architecture and the design. Right? So 5G aims to meet the needs of the future Internet of Everything, providing the support for emerging application scenarios such as autonomous driving, such as VR, AR, smart home, smart cities. Right? The strong connectivity features of the 5G facilitate the full flow of data and the information across a broader range, promote the comprehensive implementation of the new key technologies like AI, like the edge computing, like cloud computing, like big data in various economic and social fields. Right? So it's not just advanced in communication technology, also the significant milestone marking the beginning of the era of intelligence. So 5G is a general term of a solution that integrates multiple new wireless access technologies with existing evolved technologies, representing the true convergence of communication technology and the internet, far beyond the simple concept of 4G plus 1G. Okay. Then we check another concept, 5G plus X. The concept of 5GX, empowering industry digital transformation, centers on the idea that based on 5G network, based on 5G infrastructure, its deep integration with various cutting-edge technologies. That means X. To provide power for the digital upgrade for all industries. As the next generation network infrastructure, 5G is characterized by the high speed, by the high connectivity, by the low latency, low power consumption, and the ability to connect everything, the IoT, right? So it enables the comprehensive connectivity among people, among machine and items. So here, X we present other key technologies that are integrated with 5G, AI, cloud computing, big data, industrial internet, IoT. And when combined these technologies, 5G can bring about enhanced capabilities and innovative models, such as optimizing production process, improve the decision-making efficiency, and creating some new service models. So 5G provides massive and stable connections, enable the interconnection of all elements in the industrial sector. So as a platform, 5G can integrate technologies like cloud computing, AI, big data to form comprehensive solutions. For example, in the industrial sector, AI, big data to form the comprehensive, can enable the intelligent quality inspections, and also have the 5G integrate with big data to optimize supply the chain management. This integration finally reshapes the production, the management, the service methods of industries. And for instance, it enables remote surgery in the healthcare sector and creates fully connected factories in the manufacturing to enhance the production flexibility and enhance the efficiency. So in summary, 5G integrate with X, empowering the industry digital transformation. Hence a picture of a future where 5G serves as the cornerstone and through the integration and innovation of the technologies, all the industries move toward to intelligent, move efficient, and networked development, right? Okay, and next we will show you the three typical scenarios. Scenario 1, 2, 3. Focus on the ENBB, UILC, and the MMTC. Okay, the three. Okay, now we check the first one, the ENBB. The development of the future. We know the XR, right? Both AR and VR, the extended reality, including AR, VR service, indeed place higher demands on the speeds, right? On the network speeds. So as an entry point connecting the physical world with digital content, AR cloud will hold immense potential. Holds immense potential. And AR cloud service will require the real-time overlay of the digital content based onto the physical world and certain application scenarios, such as the high precision industrial guidance and social interactions. These scenarios may demand speeds existing 100 megabits. So this requires network to support low latency and the high bandwidth. And currently, 5G networks and the evolution towards 10 gigabits optical networks are lying on the foundation for meeting these requirements. Yesterday we introduced before, right? And for the AR cloud, the AR cloud is expected to become the interactive gateway between the virtual and the real world, the physical world, to giving rise to new business ecosystems. For example, in the industrial sectors, the AR technology has already been applied in the remote assembly, non-destructive testing, and other scenarios, significantly improving collaborative efficiency. And as the technology matures and network capabilities improve, the AR cloud is expected to achieve the larger scale applications in the industries such as education, such as social networking, for shopping, for travel navigation, for cloud gaming. Okay. The next page will show you the bandwidth requirement of the VR video. The bandwidth requirements for VR videos are significantly depends on the solution, based on the frame rates, based on encoding technology, based on transmission modes. And for the first one, the basic VR experience, it requires at least 10 megabits of the bandwidth to ensure the smooth viewing. And for the ideal VR experience, the high quality VR, such as 4K, 8K video and high frame rates, demands up to 2 gigabits of data traffic, so which can only be supported by the 5G network or the FTTH. Do you know the FTTH? The fiber to the home, fiber to the home. And transmitting 16K VR video requires at least 150 megabytes of the bandwidth. But in the practical applications, the experience may be compromised due to the network conditions and service limitations. So there are some challenges, such as the network latency, And VR requires end-to-end latency to be below 20 milliseconds. Otherwise, it may cause dizziness. So when multiple users access to the system, the bandwidth must need to increase. Otherwise, frame breathing may occur. And the screen resolution and decoding capabilities of the mobile device and other terminals may also limit the experience of VR. So the integration of 5G and the cloud technologies with the 5G's high speed, like 10 gigabits, low latency features will drive the popularization of the VR. Okay, this is for the ENBB scenarios. The second two, the scenario two, the URLLC, where we will introduce autonomous driving and industrial internet. Okay, first we check this one. In the field of autonomous driving, the traditional vehicle-centric approach relying on cameras, on the radar sensors and the laser rangefinders has reached its limit. And this device performs poorly under all weather, non-loss, right? The unlost conditions. Yes, they will introduce reflection and dereflection, right? Non-reflection is loss, right? But in most scenarios, it's unlost scenarios, right? So here, the device performs poorly under all weather, unlost conditions, and struggle to meet the demands of complex environments. However, the tradition of the 5G IOV, Internet of Everything, has completely transformed this situation. Through the high-speed, low-latency 5G networks, the vehicles can share the HD maps, share the vehicle-to-vehicle, vehicle-to-road data in real time to enhance the environmental awareness. For example, in the weather or the some complex scenarios, you mean how far away can cars be detected with these sensors? I don't remember the dedicated value. Maybe I can check during the breakdown and I can give you the response. All right. Maybe several kilometers. And now I will check. Yes. Okay, and we see we introduce of the 5G ILV to transform this situation through the high speed, low latency 5G networks, vehicles to share the map, share the data in real time to enhance the environmental awareness. For example, in the complex weather or some complex scenarios, the 5G IOV can still ensure precise vehicle positioning and decision making, greatly improve the driving safety. And even more existing is that 5G supports the remote driving technology to allowing the remote operator to intervene in real time in some special situations, such as emergency takeovers or some complex road conditions to provide the additional layer of safety for autonomous driving. Also for the remote driving, for the remote excavator. Here, just show you the industrial internet by the 5G technology, taking the remote control excavator as an example here. The high speed, the low latency transmission capabilities of the 5G network to enable the real-time transmission of the video, of the data connected by the cameras and sensors from the control room. Then the operators can make the process decisions and execute operations based on this data, based on this information, to improve the work efficiency, improve the safety. And in the field of unmanned mine car, the 5G technology can enable the automated transportation on fixed routes, such as shuttle bus or the port transport. In particular, harsh environments like mining areas and landfills, 5G ensures the stable operation of the vehicles. And 5G also can support the intelligent vehicles dispatching, allowing shared vehicles to be remotely directed to areas with a high demand, optimizing resource allocation. When an autonomous driving system encounters more function, the 5G network can enable the human intervention to take over to ensure the continuous operations. Then continue for the MMTC, Internet of Everything, the MMTC. For the MTC, the high bandwidth and low latency of 5G has completely resolved the transmission bottlenecks of the traditional smart homes. The high bandwidth is 10 gigabits, and low latency is reduced to 1 millisecond. 4G we say is 10 milliseconds, right? But 5G we can reduce to 1 millisecond to solve the transmission bottleneck of the traditional smart homes. For example, for the HD surveillance cameras, can now transmit real-time footage without any lag, allowing users to instantly check the status of their homes through the mobile app, with the emergency response times reduced to the unit of millisecond, And the massive connectivity capability, the millions of devices per square kilometer, the massive connectivity capability can support the stable and interconnected device throughout the home, such as the smart refrigerators, the air conditioners, the security systems, which can work together to form the scenario-based solution. Also, it has accelerated the implementation of innovative application scenarios. For instance, 5G integrated with AI cameras can analyze the abnormal behaviors in real time and issue remote warnings through two-way voice calls, uploading the HD video clips to the cloud for storage at the same time. Also, we have another example. Is a smarter mattress that monitors heart rate, breathing frequency, and other data, which transmit in real time to the health management app via 5G, allowing the doctors to remotely access the data for diagnostic assistance. Moreover, the deep integration of 5G with AI and the edge computing technologies is driving the transformation of the smart homes from the hardware skills to an ecosystem of the hardware with software with services. For example, for the customized energy management service, it's based on 5G, can optimize the operation of households by analyzing the electricity usage data to reducing the energy costs. This is the case in the smart home sector. besides smart home, also we support the smart city, right? Regarding the smart cities, for example, intelligent transportation, 5G supports the vehicle to everything. We know the V2X, right? Vehicle to everything communications, enabling the real-time interaction between vehicles and traffic lights and the roadside device to optimize the traffic flow. And also for autonomous vehicles, the autonomous vehicles can obtain the road condition information through the network, enhancing the driving safety. And in the smart healthcare, remote surgeries and high definition video consultation rely on the low latency feature of the network, allow the doctors to operate a remote device in real time and can share the medical data, facilitates the development of precision medicine. And maybe in others in smart energy, the smart grid connect distributed energy device via 5G to achieve the dynamic balance between supply and demand. Environmental monitoring sensors transmit real-time data on the air quality and the temperature and to assist in environmental decision making. So 5G provides the so many applications of the MMTC. And also we introduced another key technologies yesterday, the network slicing, right? We say 5G can provide the network slicing technologies. It can offer the customized network results for different applications, like transportation, like healthcare, to ensure the priority for crucial services. And also besides the network slicing, also 5G supports edge computing, right? By supporting the edge computing, it can reduce the data processing latency, right? And enable the real-time response for industrial robots, for the security cameras and other devices. And besides this, we say 5G can also support the connections of millions of devices, right? Promoting the comprehensive networking of facilities such as smart water meter, right? Smart water meter, and maybe the street lamps, thus facilitating the larger scale deployment of the IoT. These developments will bring both economic and social benefits. These two benefits. And in terms of economic benefits, 5G can drive industrial upgrading, such as reduce energy waste caused by the traffic congestion in intelligent transportation, and can improve energy utilization efficiency in the smart grids. And in terms of social benefit, the public service efficiency is significantly enhanced. For example, the remote healthcare, right? Remote healthcare. And for the environmental monitoring data, the environmental monitoring data can help in process pollution control, improve the resident quality of their life. So we see so many applications can integrate with the 5G network. So we say 5G means the future is now. Future is now. Okay, here is a question. Please list at least 5 applications that you are familiar with. You can type in the chat box. The 5G applications you are familiar with. VR, yes. IoT, yes. Online pay, autonomous driving, yes, correct. Also maybe the cloud gaming, right? Also maybe the remote healthcare, right? Maybe the smart factories, the industrial parks, right? All to the 5G applications. 5G remote surgery. Yes, remote surgery. Yes. Yes. Okay, let's continue. Okay, the second chapter, 5G protocol standardization and industry progress. Regarding 5G, is to establish the globally unified 5G standards. We know yesterday we introduced the different rates for 4G, for 3G, for 2G. We know during the 3G era, there were three major standards, right? Do you still remember the 3G, the three major standards for during the 3G era? The three major standards for 3G. One is WCDMA, right? It's led by Europe. The other is CDMA 2000, led by United States, and also the TD-SCDMA led by China. WCDMA, CDMA 2000, and TD-SCDMA. These standards will lead to a fragmented global market, and increase the R&D cost for the terminal for the network equipment. So this situation of the multiple standards coexisting pose the challenges for the global roaming and economies of the scale. This is for 3G. And in the 4G era, we have the LTE, right? The long-term evolution. And LTE include both FDD and the TDD, right? The duplex mode. Frequency division, time division, include both too. FDD, TDD become the mainstream standard. But the difference between these two systems still existed. For example, China Mobile adopted TD-LTE, TDD, while other operators might use the FDD-LTE. Although the technical frameworks were convergent, difference in frequency bands and difference of the network configurations still limited the popularization of global roaming, limited the convenience of the global roaming. So 5G was jointly developed by the ITU and the 3GPP to obtain a globally unified technical framework we call the NR, the new radio, 5G NR, and clearly supporting the three major application scenarios. Right, we said before, the eMBB, MMTC, and the UILC. And through the standardization work of the 3GPP, 5G has achieved a comprehensive unification from the core network to the radio interface, because it is based on SPA, right? To avoid the fragmentation issue caused by the multiple standards. And 5G coordinates the global spectrum results through the frequency band division divided by the 3GPP. One is FR1, the other is FR2, high frequency band, low frequency band, FR1 and FR2. And to reduce the cost of the IoT terminals, the Release 17 standards were introduced, the new key technologies. We say the rate cap, reduced capability, which simplifies the terminal design by reducing peak data rate, reducing the bandwidth requirements to simplify the terminal design, and promote the larger scale IoT deployment, and further expanding the scale effect of the 5G. So overall, 5G has resolved the fragmentation problem of multiple standards that exist in the 4G, in the 3G eras by establishing globally unified standards, right? To achieve the comprehensive coordination in the technology, in the frequency band, and the entire industry chain. So this goal not only enhance the convenience of the global roaming, but also reduce communication costs through larger scale deployment. Thus can promote high quality deployment of the digital economy. Okay, then for the standardization, for this one, release 15, 16, and 17. 17. We see as okay, first we need to know remember the 15. 15 is the first one release that defined the 3G from 15. Then release 16, 17 just enhanced some features. And as a significant milestone in the global mobile communication technology, the standardization of 5G began with the 15 and has been continuously optimized in the 16, 17 to form the technical framework centered on the new radio, on the NR, on the 5G. And our release 15, R15 laid on the foundation for the infrastructure of 5G by introducing massive MIMO, introducing millimeter wave technologies, which can improve network capacity and transmission rates, meet the requirements of the EMBB scenarios. And for release 16, 16 further expanded the application scope of 5G by supporting the URLC and the MMTC, right? Providing the key technology support for vertical fields, such as industrial internet, such as vehicle networking. And for release 17, we say it introduced the rate cap technology, right, to reduce the complexity of the IoT terminals and can facilitate the larger scale deployment of 5G in scenarios like the smarter wearables and the industrial sensors. And on the core network side, 5G adopts the network generation code. We say the 5GC, right? 4G we use EPC, 5G we say 5GC, 5GC. And the 5GC used the cloud native architecture and the network slicing technologies to achieve the flexible resource allocation and achieve the efficient service management, right? Just remember the cloud native architecture, the network slicing for the 5GC, for the 5G core network infrastructure. Yesterday, we introduced 4 key technologies. These are 2, right? And at the same time, the evolved version of 4G, 4G core network, EPC, EPC Plus, ensured a smooth transmission to the 5G network, enhancing the processing efficiency of the low latency services through improved edge computing capabilities. Because we supported CUPS, right? We can deploy the UPF nearest to the base station to shorten the transmission delay and improve the edge computing capabilities. Right. It's very similar to the information we introduced on yesterday's morning, right? Okay. On this page, do you still remember after on yesterday's morning after we finished the introduction, some of you asked me the question, what's the difference between NSA and SA, right? I just do a self-introduction to you. Oh, sorry, I just do a simple introduction for you, right? The construction of 5G network actually can be divided into 2 phases. The first phase is NSA, non-standalone, and the second phase is SA, standalone. In the 5G networking, standalone and non-standalone are 2 core architectural model defined by the 3GPP, And the key difference between them lies in the independence of the network architecture and the degree of reliance on 4G infrastructure. For SA for standalone means independent networking. So it is entirely built on 5G technology, including the 5G core network, 5G base station, and doesn't depend on any 4G infrastructures, right? So this architecture offers 4-5 capabilities, such as ultra low latency, such as network slicing, representing the final evolution direction of 5G, enable the full potential of 5G to be realized. So SA supports the ultra reliable and low latency communications, URLC, making it more suitable for applications that require the low latency and high reliability, such as autonomous driving, such as remote healthcare. This is for SA. Then for NSA, NSA stands for non-standalone, which means non-independent networking. So it's a hybrid architecture that use the 5G base station, but it still relies on the 4G core network, EPC. And NSA achieves 5G coverage quickly by upgrading existing 4G networks, reducing the initial construction costs and time. So its advantages include the fast deployment and the low cost. Just a transitional solution, just a middle solution. Okay. And in the earlier stage of the 5G deployment, we can opt for a hybrid networking model, combining both NSA and SA. This means the operators can provide both NSA service, which relies on the 4G core network, and the SA service, which are fully based on the 5G core network. So this hybrid networking approach allows the operator to flexibly choose the deployment models according to the business needs, according to the coverage requirements, and according to the cost effectiveness. And the term one-time implementation refers to the ability to provide both networking modes by using the 5G core networks and the base station equipment that support the dual mode operation. The dual mode operation we will introduce later. 5G we supported the carrier aggregation and the dual operation. And for this, the dual mode operation, this will eliminate the need for phased construction, accelerate the 5G deployment, reduce the initial investment costs. Moreover, this model supports the flexible marketing strategies and enabling operators to develop differentiated service plan to different user groups, to different business scenarios. Maybe, for example, for the general consumers, for the public consumers, in areas covered by the NSA, the high low cost 5G service can be provided to quickly attract users, right? And in the areas covered by the SA, premium package supporting ultra low latency, network slicing, and other advanced features can be offered to enhance the user experience, and we can increase the ARPU to increase the average revenue per user. This is for public consumer, and for the industry customers. For the industry customers, the SA model supports the capabilities such as network slicing, such as edge computing, enabling operators to provide customized services for enterprise clients, for remote healthcare, for the industrial internet. This SA model. And for NSA, NSA model can meet the basic connectivity needs, because we say for the NSA it's 4G, right? Based on the 4G base station, based on the 4G frequency band. And 4G, we used the low frequency band, right? So it can provide the wide coverage area. So here, the NSA model can meet the basic connectivity needs to form the multi-level service matrix. And the core advantages of this high networking model lies in its ability to balance the deployment efficiency with long-term evolution requirements. And in the short term, NSA can allow the rapid 5G deployment to capture the marketer. And in the long term, SA enable the full potential of 5G to be realized, supporting the innovative services. Right. Okay, on this page, it's very similar with the evolution of the standardization, right? The release 15, 16, and 17. But here, we want to take some time to introduce the details of the enhancement features. Enhancement feature, especially for the release 16. Release 16. We see the 3GPP release 16 standard was frozen in July 2020, marking a significant milestone in the evolution of 5G technology. So its core objective is to transition 5G from being usable to being useful by enhancing existing capabilities and expanding new application scenarios, thereby accelerating the implementation of 5G in the vertical industries. And new additions include enhanced eMBB, include the vehicle networking, the industrial internet, the smart grid, and unlicensed spectrum. Okay, now we see the enhanced eMBB. Enhanced eMBB. First, focus on the MIMO. MIMO includes the improvements in the multi-antenna transmission, right? Multi-antenna transmission optimization. And we also support the beam management. Because we use the beam forming, narrow beam. So we need to do the beam management and to enhance the spectral efficiency and the network coverage. And for the uplink switching, uplink handover. Uplink handover refers to the technology that ensures the continuity of the uplink data transmission when the UE moves from the current serving base station to the target base station. In the eMBB service, in the eMBB scenarios, due to the high user mobility and large traffic volumes, uplink handovers require the low latency and the higher reliability to prevent the frame freezing, to prevent the interruption in services, especially for video calls, especially for the live streaming. And for the CA and DC, CA is for the carrier aggregation, DC is for dual connectivity. These two are support for more flexible spectrum combination to improve data transmission rates and stability. And for the IAB, IAB full name is Integrated Access and Backhaul. IAB is an innovative network architecture that allows base station to provide wireless access and backhaul functions for terminal devices at the same time. So can reduce the reliance on traditional fiber backhaul and lowering deployment costs. In eMBB scenarios, the IAB is particularly suitable for the dense networking in the millimeter wave frequency band with a limited coverage, where it enhances network capacity and coverage by flexibly deploying small cells, such as micro cell. And for the UE power saving technology, the technology such as wake-up signals and adaptive MIMO layering are introduced to reduce the power consumption of the 5G terminal, right? We see when we perform the beamforming, we can save the power on the terminal side, right? Because the radius, the C radius, the beam length increased, has been increased, and the received signal transmit from the terminal to the base station also can be enhanced. So we can save the UE power. And for the interference management is key parameters to improving the performance of the eMBB networks, especially in the densely populated areas such as urban hotspot scenarios. And technologies like massive MIMO beamforming, such as dynamic spectrum allocation and coordinated interference cancellation, effective suppress cold channel interference, enhance signal quality and spectral efficiency, can ensure the user experience rate reach up to 1 gigabits, right? 1 gigabits, and can ensure the peak rate. Peak rate is reach up to 10 gigabits, 10 gigabits. And last one is SON and MDT. SON full name is Self-Organization Network, and MDT is minimization of drive tests. And these two are core technologies for the intelligent network operations and maintenance. SON reduce the network deployment and operational costs through the automated configuration, operation, and fault recovery. MDT utilize the network measurements data such as the signal strength, the parameter ISRP, right? ISRP, and the interference level. The parameter is CINR, right? Is CINR. The MDT utilizes the network measurement data collected by the terminal device to assist in the network optimization to reduce the need for traditional drive test. In the eMBB networks, the SON MDT can quickly identify the coverage holes or congested areas, thereby improving the overall network performance. These are the eMBB enhancement. Also, besides the eMBB enhancements, also we have the UR-LLC enhancement, IOV industrial network, and smart grid and unlicensed spectrum. Now check the UR-LLC enhancement. It still aims to address the high reliability and low latency scenarios, such as industrial control, such as smart grids. The R16 has implemented several features: ultra low latency, ultra high reliability, and high precision timing. For ultra low latency, the air interface latency is reduced to 1 millisecond, right? Half to 1 millisecond. And end-to-end latency is compressed to less than 5 milliseconds. And for ultra high reliability, network reliability is improved to 6 nines, right? We said on yesterday morning. The ultra high reliability, the network reliability is improved to 6 nines, meeting the industrial grade requirements. And for the high precision timing, support the synchronization accuracy at the microsecond level to ensure the temporal consistency for coordinated operation among the devices. This is for UILC. And for the V2X, I16 defined the NR Sidelink direct communication technology for the V2X to support the vehicle to infrastructure collaboration for the enhancement scheduling for the perception. And the vehicle to vehicle or the vehicle to infrastructure collaboration optimized the multicast and the broadcast enable scenarios such as the semi-autonomous driving, and perception and enhancement scheduling. For this one, improved the communication quality, supports applications like extended sensors and the remote driving. And for the industrial internet and the smart grids, we have the NPN, we have the 5G LAN. 5G LAN to support industrial local area networks to enable the low latency direct communication between the devices. And for the NPN, do you know the NPN? Here, to be capability building, we have the NPN. What's the meaning of NPN? Full name is non-public network. It's used to provide the isolated dedicated network for the industry users to ensure the data security. This is NPN. And also we see the smart grids. Smart grids, it can support the crucial applications such as differential protection and automated control through the UILC and the timing technologies. And the last one for the unlicensed spectrum. The Release 16 expands the 5G deployment capabilities in unlicensed frequency band, like the 5 GHz, by using the dynamic spectrum sharing technologies to improve the spectrum utilization and can reduce the deployment costs. And for the NB-IoT, do you know the NB-IoT? Yeah. Where's this one? The NB-IoT evolution. NB-IoT, especially for the low power wide area network, right? Let me type in the chat box. LPWAN. This one. The full name is low power wide area network. This one, LPWAN. NB-IoT is a low power wide area network technology based on the cellular networks designed for the IoT service. It features wide coverage, low power consumption, and low costs. So its core advantages include the low power consumption, wide area, low cost. And for the low power consumption, what's the meaning of low power consumption? The terminal model can operate for up to 10 years on standby, make it suitable for the battery-powered sensor devices. This is for low power consumption. And for wide coverage, NB-IoT can provide around 20 dB gain compared to the traditional networks, improving the coverage capability by a factor of 100, making it more suitable for the complex both indoor and outdoor environments. And for the low cost, the cost of the model can be reduced to around 20 RMB to 30 RMB, facilitating large-scale deployment. And this is for the enhancement point of the enhancement feature of the Release 16, right? And after the Release 17, the 3GPP began researching the integration of the NTN with NB-IoT, aimed to expand the coverage of the IoT service through the satellite networks, and address connectivity issues in the areas not only covered by the Earth networks. Do you know the NTN? NTN, not NPN, okay. NPN is non-public. Here I see the NTN. NTN is we refer to as integrated space air ground networks. It's a type of the network that include nodes not located on the Earth's surface. It aims to achieve the global coverage through satellites, the high altitude platforms, and other means on complementing the limitation of the communication networks by coordinate the satellite, the GEO, MEO, LEO, with the gateway station and the core network. This is after the release 17 for the 5.5 for the 6 GHz. Okay. Oh, sorry. Okay. And we know 5G really E2E, end-to-end products and solutions for the device, for the product. Always 5G end-to-end products demonstrate strong adaptability to various scenarios in the real-world deployment. In densely populated urban areas with the high antenna density, while we can use the massive MIMO AAU like 64T or the 32T massive MIMO AAU to achieve the 3D beamforming, accurately control the coverage radius, and significantly improving the capacity of the system and improve the user experience in the high-rise building and densely populated areas, right? And in scenarios requiring continuous coverage in subways, we use the Huawei's easy macro devices, which are highly integrated, replace the traditional liquid cable, reducing the construction costs by 50%, and can shorten the deployment time by 60%, while also supporting a high precision positioning and multi-service capabilities. And for some indoor hotspots areas, for the high traffic areas, we have the indoor solution. We say the lamp site. Yesterday we introduced the digital indoor solution, DIS, right? We compare DAS and DIS. Yeah, for the indoor hotspot or for the high traffic areas, we can use a lamp site digital indoor distribution system to enable the precise capacity allocation. And the BLAD AAU simplified the site solution, allows for the rapid deployment to meet the high bandwidth demands. And the four technology baseband capabilities achieved through the full cloud-based core network, and through the SuperBand 2 technology to enable the seamless coordination among 2G, 3G, 4G, 5G technologies, perform the smooth evolution between the NSA and SA to ensure the network continuity and service flexibility through these devices, end-to-end products and solutions. And at the same time, Huawei offers a wide range of the 5G terminal products that covers for signal person, for the home, for the industry application scenarios. This terminal mainly include 5G smartphones, 5G cell phones, 5G CPE, 5G models, and others. Here for the CPE. Do you know the CPE? CPE full name is Customer Premises Equipment. Let me type in the chat box. USEOMER. This is a CPE. 5G CPE is just a device that can convert the 5G signal into Wi-Fi signals. Convert 5G signal into Wi-Fi signal, functioning similarly to a more powerful mobile hotspot. And the features of Huawei's 5G CPE Pro series products, such as CPE Pro 2, we have some features. One is to support both SA and NSA, support both two dual models, compared with 4G and 5G networks, enable the seamless upgrades. And also they use Huawei's on-chip. Huawei's on-chip can offer the theoretical peak download speed up to around 3.6 gigabits to support advanced technologies, such as the super uplink, such as the network licensing, and make it more suitable for the scenarios like the HD live streaming or like the AR, VR, like the clouding games. And beside the CPE, also the 5G models for the applications in the computers, in the drones, and more, and more. Okay, now we check some details for the 5G models. Here, 5G models commonly use the two types of the integrated circuit package technologies. One is M2 packet, the other is LGA packet mode. What's the difference? Okay, for the first one, the M2 package mode is a compact board mounted connector standard, characterized by the model being connected to the M2 slot on the motherboard via gold fingers. It supports multiple protocols, and is allowing for its small size and flexible interface. Okay, now you need to remember the feature of the M2 packet node, a small size, flexible interface. So in 5G models, the M2 packet node is often used in the device, such as laptops, such as routers, enabling the quick integration of the 5G functionality through the plug and play method. This is for M2 packet mode. And for the LGA packet mode, LGA full name is Land Grid Array. It's a technology that directly solder the chip pins onto the PCB in a grid array pattern. So its characteristic is that the pins are located at the bottom of the chip and are connected to the motherland via solder pads, offering the advantages such as the stable connection and good resistance. So in 5G models, LGA package mode is usually used for the industrial grade or the automotive grade models that require high reliability, ensure the stable operation in harsh environments. So the choice between these two modes depending on the application scenarios. The first one, M2 packet mode, depends on the application scenario. The M2 packet is suitable for the consumer grade, device that requires the flexible plugging and unplugging, right? But for the LGA mode is more suitable for the industrial or the automotive 5G models that demand high reliability. M2 like storage units, yes. And for the 2-bit device ecosystem overview, for this one, the 5G 2-bit device ecosystem refers to a collection of devices that provide the network connectivity, the data collection, and intelligent process capabilities for vertical industries such as industrial manufacturing. Right. So the core objective of this ecosystem is to meet the high demands of the industry for the network performance, for the security, for the flexibility, so to drive the enterprise digital transformation. And the key devices include 5G industrial CPE, 5G industrial cameras, and 5G industrial smart gateways, which enable the device interconnection, real-time data transmission, and edge computing through 5G networks. Okay. For the first one, 5G industrial CPE, it's a critical hub connecting industrial equipment to the 5G network. Its main function includes multi-network supporting the data connection and transmission and wireless coverage. This is main function. Three parts. First one, for the multi-network support, it supports a seamless switching and redundancy backup between 4G and 5G and the satellite communication links to ensure the uninterrupted communication. And for the data connection and transmission, it connects to various sensors and uploads data to survivors in real time, supporting remote monitoring and intelligent operations and maintenance. And for wireless coverage, deploy the wireless access point, deploy the wireless AP at the industrial site to build the widest network covering the entire area, supporting the mobile device access. This is for the industrial CPE. And for the industrial cameras, the industrial 5G industrial cameras are the core equipment for the industrial vision inspection with some features. Also, the first one is wireless transmission. Then we can focus on the deployment, simplified deployment. And other features like the AR integration, like the edge computing. This is for the industrial cameras. Then for the intelligent gateway, the industrial intelligence gateway, serves as the data processing and communication hub at the industrial site. The core functions include the protocol conversion, the edge computing, security isolation, flexible networking. So these three types of the device together can form the core of the 5G 2B ecosystem. CPE responsible for network connectivity. Industrial cameras enable the visual perception, and the smart gateways handles data processing and edge computing. Right. Achieve the high speed and achieve the low latency features of the 5G networks. Empower flexible manufacturing, intelligent quality inspection, and remote maintenance scenarios in the smart factories, right? In smart factories. Okay. A question for you. Which part of the 5G industry chain is the fastest growing and which is the slowest? Please give a brief description. Please type in the chat box. You can guess. Which part is the fastest growing? Which is the slowest growing? Actually, we say the fastest growing segment is for the equipment components. Equipment components such as base station, antennas. The market size of this segment is expected to grow by nearly 160% compared to the 4G, representing the largest growth potential. So this is due to the surge in the demand for components such as antennas driven by the construction of 5G base station. So equipment components in the 5G industry chain is growing fastest. So, and which part is slowest growing? Slowest infrastructure deployment. Devices are growing faster. Service applications. RAN or code is growing slower. And more correct answer is the optical models. Optical models is the slowest growing segment. Because the optical model market is expected to grow about 3 times, compared to the 4G, but at a relatively slower pace. At a slower pace. In addition, domestic companies mainly produce mid to low-end products, such as 25 GHz optical models, while the high-end market over 100 GHz is still dominated by the foreign companies. So optical models is the slowest. Hardware, the physical segments grow slower. Yes, it's the hardware. Yes, service and applications. Now we continue. The chapter 3. For the chapter 3, the 5G transformation and network evolution. Okay, on this page. Okay. As the next generation mobile communication technology, 5G's core capabilities are supported by so many technologies, so many key technologies, like the ultra high data transmission rate, right? We say 5G, the ideal target is 10 gigabits per connection, right? And for the ultra low latency, reduced to 1 millisecond, the end-to-end delay, the end-to-end latency, and the massive connectivity, reach up to 1 million connections per square kilometer. High-speed mobility for the railway, high-speed railway reach 500 kilometers per hour. And the network slicing technologies. And yesterday we introduced the 5G new architecture, right? 5G new architecture. And now we focus on the first one, the ultra high data transmission rate. The 5G achieved the NR, the new radio technologies, and the massive MIMO, extremely high data transmission rates. And NR significantly improved the spectral efficiency by utilizing wider spectrum bandwidth, such as FR2, such as millimeter wave, right? The cell bandwidth can reach up to 400 megahertz after the cell aggregation. And advanced modulation and coding schemes, such as 1024 COM and massive MIMO. On the other hand, provide the higher network capacities in dense urban areas and other scenarios through beamforming technologies, preventing the network congestion. And for the ultra low latency, achieving 1 millisecond end-to-end latency requires the coordinate optimization of multiple technologies. Network slicing technology provides isolated and such as industrial control and remote healthcare. This is for the customized logical networks for the different services to ensure that critical services receive the dedicated bandwidth and the latency guarantees. And also for the UPF deployment, we deploy the UPF at the edge of the base station and deploy the edge computing. The edge computing move data process capabilities closer to the network edge to reduce the distance data needs to travel, and thus lowering latency, shorten the latency. And for the connectivity, 1 million connections. Based on the new architecture, we say 5G core network is based on the SPA, right? The SPA, the service-oriented architecture of the 5G core network. And the lightweight protocols support the massive device connectivities through the cloudification, the virtualization, and microservices in the core network. 5G can efficiently manage the access and resource allocation in a large number of terminals, meeting the needs of the IoT scenarios. And for the high-speed mobility, 5G supports advanced mobility management technologies and more efficient handover mechanisms, enable stable connections in high-speed mobile scenarios, such as the high-speed train, high-speed railway. And the radio technology optimizes the signal coverage and the handover process to ensure users can maintain smooth network services even while moving at a high speed. And for the network slicing is a hallmark technology of the 5G standalone networking for the SA. It provides end-to-end logical dedicated network for different industries, by the isolated slice across the RAN, the wireless network, across the transportation network, transmission network, and the core network. And the slice management functions such as the NSMF manage the entire life cycle of the network slice to ensure the coordination among the sub-slice and guarantee the service level agreements. This is for the network slicing technology. And for the new architecture we introduced yesterday, SPA, the service-oriented architecture, service-based architecture, which modularized the network functions into independent services and enable the interaction through the service-based interface. And this architecture supports the flexible combination and expansion of network functions, providing the foundation for new services such as network slicing and edge computing. Therefore, through the new key technologies of 5G, including new radio technology, network slicing, new architecture, edge computing, it is possible to achieve the goals such as 10 gigabits per connection, 1 millisecond end-to-end latency, 1 million connections per square meter, and high-speed mobility up to 500 kilometers. And the rapid, how does the architecture achieve 1 millisecond latency and slicing for a train while undelivered? For your question, actually in the live network, if you want to achieve the 1 millisecond latency, we can deploy the UPF clear to the base station to shorten the retransmission distance. This is first way. And we can choose the dedicated network slice for the scenarios. We have the URAOC slice, right? Yesterday we said now we already have 4 dedicated slices for ENBB, URLC, MMTC, and the V2X, right? So here we can select the URLC network slice for the industry for the deployment, right? And for the train at 500 kilometers per hour, that means in the high-speed railway, just the faster change, right? The channel condition is faster changed. So in this case, we can change the resource allocation schemes, maybe for the modulation scheme and for the coding scheme, we can choose the QPSK. Because in this case, the channel condition is changed fastly, right? So we can need to allocate so many feedback results and give the rapid feedback to the base station and adaptively adjust the modulation scheme, adjust the scheduling scheme, and adjust the coding scheme. So many key technologies work together, then we can achieve the 1 millisecond latency. But actually, in the live network, for the common consumers, we cannot achieve 1 millisecond latencies. It's only in the experiment, in the equipment room, and with the best transmission condition, we can reach up to the 1 millisecond latency end to end. It's very difficult to achieve this goal. Okay, and on this page, the key technologies for 5G and acceleration. Now, the rapid development of the 5G new radio relies on the collaborative innovation of the multiple key technologies which work together, enhance network speed, capacity, efficiency, and the coverage capabilities, providing the strong support for the rapid growth of the mobile internet and the Internet of Things. The first is the new spectrum. Yesterday, we introduced the frequency results for you, right? We introduced FR1, FR2. FR1 divided into sub-3 gigahertz and the C-band. And for FR2, similar to refers to the millimeter wave. So here, the new spectrum is C-band and millimeter wave. Right? 5G has gained access to the larger bandwidth results by using the new frequency band, such as C-band, millimeter wave. For the millimeter wave bands, such as 24 gigahertz to 30 gigahertz, such as 37 gigahertz to 40 gigahertz, offer up to 400 megahertz cell bandwidth, and 800 megahertz carrier aggregation capability. Increase the peak data rate for the individual users. In practice, downlink rates can exceed 3.7 gigabits. 3.7 gigabits. And for the C-band, usually C-band we use 3.5 gigahertz. This is a mainstream, 3.5 gigahertz. But we need to deploy the 3.5 gigahertz together with the key technologies, uplink and downlink decoupling to resolve the unbalanced problem. And the second one is the multiple antennas, the massive MIMO. Massive MIMO, we say multiple input, multiple output. This technology can improve the spectral efficiency and the network capability by deploying the ultra large antenna arrays, such as 64 TRX or more, right? Or more, and using the spatial multiplexing to serve multiple users. Use the same frequency band to transmit at the same time. This is MU MIMO, right? The MU MIMO. And the release 17 standard to further enhance the multi-TRP transmit and receive point. Enhance the multi-TRP deployment and multi-beam operation capabilities. The release 17 standard further enhance these two features to optimizing signal coverage and energy efficiency. And the third aspect is the efficiency improvement, new waveforms, modulation, and coding. New waveforms is FOFDM, the flexible or signal frequency division multiplexing, supports more flexible spectrum allocation and subcarrier configuration, adapting to diverse service requirements. For new modulation, we can select the high order modulation when the channel condition is good enough, is stable enough to increase data transmission rates. New coding here we used the Polo code and LDPC code. LDPC code are normally used for the data channel to support high speed transmission, reach up to 10 gigabits. And Polo codes are only used for control channel, for control channel to achieve the ultra low latency, 1 millisecond, and high reliability. The error rate as low as 10 upgrade -8, marking them suitable for the critical applications such as autonomous driving, such as remote healthcare. Use a Polo code. And these technologies collectively drive the application of the 5G in three major scenarios, right? The eMBB, MNTC, UILC. And through the deep integration of these technologies, 5G NR not only achieve a leap in the network performance, but also lay a solid foundation for the digital transformation across various industries, right? Okay, therefore, the spectrum, the planning of the spectrum, maybe we can have a short break, right? We can have a short break for 10 minutes, right? We have 10 minutes, and after 10 minutes, we come back and continue the remaining part. Okay? Okay. Hello guys, are you back? Yes. All right. And before we start the remaining part, I want to reserve a question. Right. Uh, on the first class, someone asked me the distance. How long the distance can the sensor detect? Right. For the autonomous driving, and I checked the information for the roaming. For the sensor, the long distance is around 250 meters. 250 meters, and the middle is around 100 meter, and the minimum distance is around 30 meters. 30 meters. So normally, is 200 to 300 meters. The long distance to detect. To detect. Okay, now we continue for the spectrum planning. For the spectrum planning. Okay, the planning of the 5G spectrum covers a wider range from the low frequency to the high frequencies, right? From low to high, with a different frequency band serving the different network functions. For the low frequency bands below 6 gigahertz, focus on the coverage and focus on the mobility. And frequency band below 6 gigahertz, especially the sub-3G below 3 gigahertz, some mid-frequency bands from for the 5G core networks to achieve the wide area coverage and ensure the mobility. For this frequency band have the favorable radio wave propagation characteristics and with the strong with a strong diffraction capabilities and the good building penetration enable them to effectively cover the extensive areas such as urban indoor and outdoor environments, such as suburban areas and roads. Thus ensure stable network connections for users moving between different locations. And for the mid-band, the C band, from 3 GHz to 6 GHz, this band we use to balance the coverage and capacity. The C band is the primary frequency band for the 5G, as it effectively addresses both coverage capacity issues, can achieving the good balance between network coverage and capacity. This frequency band offers abundant spectrum results compared with the low frequency band, compared with the sub 3G. The C band can achieve can offers the abundant spectrum results and can provide at least 200 MHz of the contiguous global bandwidth, make it essential for supporting high speed and high capacity 5G services. And for the high frequency band, the millimeter wave above 6 GHz is for the ultra high capacity and for the hotspot scenarios coverage, commonly referred to the 24 to the 52, like this. And for the millimeter wave, we have some typical scenarios. Let me check. Maybe next page will show you. We find here on this page, we will introduce the details of the millimeter wave applications. Okay, so in summary, the planning of the 5G spectrum is a system, right? Coordinate across all the frequency band. Low frequency band below 6 GHz ensure basic coverage and mobility. And mid frequency band, C band, serve as the main frequency band, balance coverage and capacity. And for the high frequency band, millimeter wave above 6 GHz provided ultra high capacity to meet the high speed requirements in hotspot areas. Now we check this page. In the radio spectrum management, different frequency bands are allocated to various services based on their physical characteristics. And the mid-frequency bands typically offer the good coverage and the moderate bandwidth, making them important resources for mobile communication, for broadcasting, and other services. And contiguous spectrum refers to the frequency band on the X that are not occupied by other services. Having the large contiguous bandwidth is crucial for modern communication technologies requiring high-speed data transmission, such as 5G and 6G, because it supports greater capacity, supports higher data rates. So in the development of the new generation mobile communication technologies like 5G and 6G, the industry is increasingly focusing on acquiring large contiguous spectrum resources in the mid-frequency bands, 3.5 GHz and 4.9 GHz, to meet the growing demand for data traffic and low latency applications. This helps balance the coverage area with network capacity and is a key focus in current global spectrum planning and allocation efforts. Okay. I'll show you, right? The topic 3.5 GHz becoming the mainstream globally, right? The allocation of 5G spectrum. Here is just the 5G spectrum in China. in China. You can check for allocate for three operators: China Mobile, China Telecom,